All right. Let's play. Let's play. Let's see how we do.
Are we going to do that tape again?
No, not yet. Let's. No Chromebooks needed. All right, so ladies and gentlemen, just wanted to make sure we are still okay with. Some of you still need to finish up tests. A couple of you came in yesterday. Thank you very much for coming in and finishing up. Some of you are still missing your take-home test, which that's worth points. So please make sure you get that to me. It was a newer concept. Everyone agrees with that, right? So let's just talk through it. So let's take a look at number one. Might as well start there. All right. So problem number one, and if you have it out, please write down anything you need to, including notes. So we have y equals x plus 1. And let's just back up a smidge before we start really getting into the nitty-gritty of this problem. We did start this unit saying, hey, we can have two linear equations, that form straight lines on the same graph. And there's three different situations that can take place. I'm using the same xy axis. They cross each other, which gives us one solution right at that xy spot. Do you agree with that? Yes. So that in order for it to be a solution to the system of equations, it would have to be on both of the lines, which if you have two lines that intersect each other, that indeed would happen. There is the scenario where they have the exact same slope, but they have different y-intercepts. So they are parallel to each other. They don't ever cross each other. So we don't get a solution there. So there's no solutions. It won't cross. And then there was also the time where we could have the exact same line lying on top of itself, which that would mean we have infinite solutions. But then we started talking that sometimes graphing isn't the best way to see these, especially if they intersect way off the graph. Does that make sense? And then there was one other time when it's not the best. You saw yesterday. What did we do yesterday? Sometimes they crisscross each other, but what happens when they cross? Yeah. No, it could be off the graph, but the other one where do what? It does create a point, but sometimes that point might not be.
Oh, it might be like a decimal.
Yeah. Big old decimal. Hey.
Right.
Are you ready?
Yeah.
Cool. Welcome. Let's see. I got you.
God! Sorry.
Oh.
You know what? Go sit outside. You sit right back there behind Tristan. Welcome. You're right. All right. So, if you have a decimal or a fractional amount, that becomes really hard to graph it. Okay? It becomes really hard to graph it. So, then we introduced yesterday, we talked about substitution might be a way that we can also start solving problems. Sometimes the equation presents either the x or the y variable. So if it's like y equals, it'd be a horizontal line. If it was x equals, it'd be a vertical line. And then, bless you, and then you have the other equation right there. Sometimes you're presented one of the variables in the system of equations. You just have to plug that in the other one to find it. But like problem number one, we have y is equal to the relationship of x plus 1, and then y is equal to the relationship of 2x minus 1. This would probably be a pretty easy problem to graph, but we want to do it by substitution. So I know that y is equal to this, and y is also equal to this. Does that make sense? So if I take the x plus 1 of the first equation, and I say, well, that's got to be equal to 2x minus 1 of the other equation, that'll work for me. Okay, let me just stop there. You see what I did and why I did it.
So they're both equal to y.
They are both equal to y, so I can set them equal to each other. So if you had like y equals a smiley face and y equals a palm tree, you can say smiley face equals palm tree. I know that sounds goofy, but that would be one way to look at it. All right, so we know that x plus 1 is equal to 2x minus 1 in this particular equation. So now that becomes first or second week of Algebra 1, solving it. So I want to get x on one side and all the numbers on the other side. Okay? Could I have x equals over here, or x equals, does it matter which side x is on? Nope. So let's start solving it. So I might say, well, we might do this. So that cancels that. That gives me this. 2x minus x is x minus 1. What do you think? So what am I going to do to get x all by itself now? I'm going to add 1 to both sides. So what does x have to equal? I know that 2 is equal to x, but then what else? So yeah.
When you subtracted the x, you're just basically just getting rid of the 2. Put an x.
So this is 1x, isn't it? We're lazy as people. We don't like putting the 1 in front of it. So that's a 1x. So 2x minus 1x is just 1x. And then 1x and x are the same thing. So I know that x is equal to 2 on this one. So far, yeah. Let's see, could it be negative 2? Let's see, I would have to add that, right? So that cancels. So 1 plus 1 is 2. Let's see, if I solve it a different way, let's see this. So did you solve this a little different than we did? I mean, I could have done this. I could have went this way. I could have said subtract 2x. That would have given me negative x plus 1 equals negative 1. Subtract 1, subtract 1. So negative x equals negative 2. And then I have to multiply both sides by negative 1, so that still gives me the same. Right? Yeah.
But when you minus 1 from that side and minus 1 from the negative 1, wouldn't that be a positive 2?
Because you go more negative. So if you owed somebody $1 and owed somebody else $1, you owe $2, right? All right, so this is an ordered pair, and I have my x component. I need to find my y component. So which equation would we plug into? Yeah, pick one. So because if remember yesterday when we had the two lines drawn crisscrossed, the dot in the middle where they crossed was on both lines, right? Dot in the middle is where they're on both lines. So I just have to pick. So I can plug it in right here, or I can plug it in right here. It doesn't matter. It's going to give you the same answer. So if I plug it in here, If I plug it in here, I get 1 plus 1, which is 2. If I plugged it in here, I'd get, that was it. Oh, shoot. If I plug a 2 in, I just goofed up. Man, I'll tell you. Look over there real quick. 2 plus 1 is 3. If I plug 2 in here, 2 times 2 is 4. 4 minus 1 is 3. So this is where the two lines would have crossed each other. That's the point. That's the point on both lines. Okay? So let's see if we can edge to number 2. Okay? Number 2 isn't just set up as y equals and y equals. Can I move off here? Okay, so at number 2, I have y equals 1/2 x plus 4, right?
And then 2y plus 2x equals.
Yeah, okay. Now, here's a quick question. Do I know that x equals something or y equals something by looking at the two equations? So one of them that's set up to present, yeah. Yeah, y is equal to this right here. Agree? Does my other equation have a y in it? Yeah. Okay, so I'm going to take this, and I'm going to plug that right in there. So I get 2 parentheses plus 2x equals 2. This had been this y right here. Agree? This had been that, but what's going to go in place of that? 1/2 x plus 4. So what I did is I took something from one equation and I substituted it into the other equation. We need to distribute over the parentheses. So 2 times half. 2 times half is 2 over 2. 2 over 2 is 1. So this becomes just 1x or just x. And then 2 times Positive 4 is 8 plus 2x equals 2. Does that mathematically make sense what we just did? So I found one of the variables was equal to not a number, but kind of like a number with letters and stuff. And I took that and I plugged it into the other equation. So the x plus 8 plus 2x equals 2 is like second week of Algebra 1. Let's combine any like terms. Do I have like terms on the left side? I have x and I have 2x. If I add those together, what do I get? 3x. So I get 3x, add the 8 equals 2. So if I continue to solve this, what should be my next step? Subtract 8, yeah. Okay, so those cancel. That leaves me 3x is equal to 2 minus 8. 2 minus 8. I have $2 in my pocket. Some cost negative 6. Good. All right. And then divide each side by 3. So I do find that x is equal to negative 2. So part of my answer is negative 2. That's the x component. I need to find the y component. Okay? So remember, those two linear equations, if they cross each other at a point. And I'm pretty sure they cross each other because you know what? I found my first part. I know negative 2 in the x direction, there's going to be a crisscross of two lines. So let's figure out what the y component would be. So that means that, so if I had these graphed, these are two lines that are going to cross each other, and this would be, you know, at negative 2 comma something. This point exists on both equations. So which equation should I plug in negative 2 to find my y component? Yeah. I could plug it in the bottom one, okay? And I agree with you. I just want to show you one thing. So I think I could totally plug it in right there. But what letter am I trying to solve for? I'm trying to solve for y. Does the other equation present y easier?
Yeah.
Does that make sense if I said that?
Yeah.
What letter am I looking for? Y. Y. Well, this is y equals. So if I take that and I plug it in there, they'll both give me the exact same answer, but sometimes one of the equations is written in a way that we can see it easier. Yeah.
And it would be a smaller process.
It'd be probably a little bit less, yeah. Because think about it here. This is already y equals, so then just do the math. This you would have, if you plug it in here, you'd have to subtract it, then divide everything by 2, but it's the same answer. But that's what the cool thing. So if you see it right away doing a second equation, please go for it. It doesn't mean you're doing it wrong. It just sometimes one of the equations might present the letter you're looking for easier. Okay, but it's still going to be the same exact answer no matter what. So I'll show you both ways though. So let me take the negative 2 and plug it in here. So I get 1/2 times negative 2 plus 4. What's half of 2? 1. What's half of negative 2? Negative 1. So negative 1 plus 4 is 3. So just for laughs and giggles, let's plug it in here. I get 2y plus 2 times negative 2. So that's negative 4 equals 2. Okay, so that's 2y minus 4 equals 2. I'm going to add 4, so I get to 6. Right? So I just gave you the opportunity to take a look at the first two. Will you take a look at number 3 and see if you can start working through it a little bit? And you can work on your own sheet. You can put it on a separate sheet of paper if you'd like. See if you can figure this out. See if you can figure it out. We do have a letter it's presented to. All right. Have you got a start on it? Do we know what one of the letters is equal to, even though it's a big thing?
Yes.
Do we know y equals something?
Yes.
We know y equals something? What does y equal?
Y. Negative x plus 1. You can like flip it.
Y equals 1.
Y equals, oh, okay. But do we know what x equals because of the second equation?
Yes.
Yeah, so where should my substitution take place? Should I go and work out one of my equations to get y by itself? Sometimes. But do we have x presented to us?
Yep.
Yeah. All right, so I'm going to take this right here, and what am I going to do with it?
Plug it into the top half.
Put it into the other equation for the x. Okay? So I have 1/2 y plus 2. That was the x. What comes next, according to my first equation?
Minus y.
The minus the y. Good. All right. The F word's up there. Fractions. Okay? I taught you something earlier in the year to not worry about fractions. What did we do? What step took place? What?
Multiply
Everything by?
2.
Yeah. So you could go and try and work this going, okay, if I add 1/2 to negative y, it comes out to negative half y. But fractions aren't our best friend. So if I multiply each of these, I'm just going to clear the fraction. Is 2 and 2 over 1 the same thing? Okay. What happens here? What happens right here? They cancel. Yeah. So I can just get 1y, which is y. And then this becomes what? 4. Minus, what does this become? Minus 2y, right? And what does this become? 2. Lush, we no longer have a fraction to deal with. Now, is that the right way to do it? The nice thing is if you don't have to deal with a fraction, fractions create anxiety. We know that. But if we learn a way that we can manipulate our equation, it's still going to be the same answer, and we don't have to work with a fraction, which is sweet. All right, so I have on this, so does everyone feel comfortable from here to here? The blue to the red, it's the same equation. They're still equivalent forms. I just don't have a fraction on the red. Do I have like terms on my red now?
Yes.
Yeah, I have y and I have minus 2y. If I combine y and minus 2y together, what do I get? Do what? Careful.
Negative 1.
That's a 1, right? So 1 minus 2, negative 1, right? So negative 1y, which is negative y. I solve the plus 4 equals 2. How do I solve this? What should I do next?
Subtract 4.
Subtract 4 from both sides. Let's do it. If negative y is equal to negative 2, what does y have to equal? Y has to equal 2. Okay, and again, this is an ordered pair. That's my y component. I know that y is equal to 2. Remember, these are two lines that happen to cross each other. They share that point. So that point right there has a y component of 2. We need to figure out the x component. So we want to take our y value. We want to take this value right here and plug it in either here or here. So plug it into either of the two first equations. Now, quick question before you jump ship real quick. What letter am I solving for now? I'm solving for x. Does one of the equations say x equals? Yeah, the top one or the bottom one? Bottom. So this would make sense to plug this 2 in right here. Okay, so I have x equals 1/2. It was a y, but now it's going to be a 2 plus 2. What's half of 2? 1. If I add those together, what do I get? 3. So the solution to this problem is 3, 2. If we had graphed it, they would intersect at 3, 2. Okay? If I were to plug in the solution to both of the equations, because it lines on both lines, I get true on both. I wind up on the top one getting 1 equals 1. On the bottom one, I wind up with 3 equals 3. Yeah.
Are there any ways to do this on a graphic calculator to make it easier?
Oh, yeah, baby. Well, it's matrix theory, and we're not going to deal with matrices.
That's too hard.
It's just a different way of thinking. Doing it by hand is a longer version, but if you understand matrices on a calculator, there's something called row reduced echelon form, RREF. It exists on the calculator. You hit that, this matrix, boom, there's your answer. Unfortunately, there's a lot of other steps of math that have to take place before I get to a matrix. Matrix math is awesome. All right. Do we feel okay on the first 3 problems? Okay. So let's take a look. I'm just looking and seeing what we got. Okay. So let me ask you this. Numbers 4, 5, 6, 7, 8, or 9. They are all going to be done in a similar fashion to what 1, 2, and 3 are done. Do you agree? So I will allow you to pick one more of those when you take a look at it. Is there any of those that you want me to take a look at? I would say in the 7, 8, 9 range. Go ahead.
Can you do 8?
I'm hitting 8. 8's the one. Okay? Okay, we want to use substitution. Okay, do either of the linear equations have x equals or y equals? No. So does everyone agree with what I just said? And I agree. It is a no. So we don't have one of the equations that has x equals or y equals right now. Okay. Could I, using that top equation, the x minus 2y equals negative 6, could I add 2y to both sides and get x equals? That makes sense how I just said that? So if I take that top equation, if I just did this, if I said, let's add 2y to both sides, that cancels that. That's going to give me x equals 2y minus 6. Is this x minus 2y equals negative 6 an equivalent form of this?
Yes.
Yeah, what I did to one side, I did to the other. It stayed balanced. So now, quick question. I now modified the first equation. Do I have x equals or y equals? I have x equals. Agree? So I'm going to take what x equals, which is this. Okay, x is equal to that, and I'm going to plug it in right there. Okay, can you see how that manipulation took place? So let's go ahead and do it. So I'm going to use the second equation. I'm working with this one. So I have 3, I have a blank there, plus 5y equals 26. These were the same. What had been here? What was here originally? X. What's now going to go there?
2y minus 6.
2y minus 6. Let's stop. Do we feel comfortable with what's up there? Yeah? Is that right? How am I going to go ahead and start solving that purplish color?
Distributed.
Yeah, I need to distribute the 3 over the parentheses. So I'm going to distribute here and here. 3 times 2y is 6y. 3 times negative 6 is negative 18. Plus 5y equals 26. Is that okay?
Yes.
Is there any part of that math that you need a little more clarification on? Okay. Do I have like terms on the next step down? Yeah, what am I going to combine? Yeah, the y's. Which, if I add 6 and 5 together, what do I get? Yeah, baby. Add the 6y and the 5y together, you get 11y minus 18 equals 26. Stop there. We good? What's the next step?
Add 18.
Add 18. You're, man, good job. So I'm going to add 18 to both sides. I'll just show it because sometimes when you get a larger number than a single digit, it's like, where'd that come from? what is that, 44? Is that 44?
Yeah.
Hey, what's y have to equal then? 4. So y equals 4. So my y component is there. What component am I now looking for? I'm looking for x. So are either the two originals or the original modified, being the red, x equals? The original modified one, right?
Yeah.
So this y value is going to go right there. So I'm going to bring this equation down. This is going to be x equals 2 parentheses minus 6. What was here? Y. What do we know that y equals? 4. So I'm going to plug 4 there now. Okay, do the arithmetic. I get 8 minus 6. If I subtract 8 and 6, I get 2. If I had graphed these equations, these would have intersected at that point, which would have been 2 comma 4. 2 comma 4 is the solution. If I take 2 comma 4 and plug it into either of the original equations, I wind up with, on the top, having negative 6 equals negative 6. That's true. And on the bottom, I wind up with 26 equals 26. That's also true. Okay? All right. I want to hit notes. I'm not collecting those yet. Okay? They will not be collected today. Okay? Let's hit some notes. I only have 4 slides on notes. It's short. Or SM all. Oh, an after one? Yeah, I'll take it out. Thank you.
I have this one too.
Thank you, sir. Hold on right there for a second. I'll be right back.
I turned in one time.
Yes, you did. And I have to hand that back out. I'm sorry. I forgot to hand those out. All right. So coming back out to you is old homework. So grab yours, pass on the rest of the pile, and then there you go. That's old homework. Does anybody have old homework they need to submit to me? Anything old you need to submit? We all right? Hey, Ren, what class were you in? You were in accelerated with. Were you there the whole time, or no? You don't have to. So you went and bought this book. What I'll do for you, because we're almost at the end of the semester, and you too. I'm going to print off the rest of it, and I will get it to your class to you guys today. So don't worry about going over it. I'm just spending like $5 a day. So we only have 3 weeks left. So I'll get that all printed up for you. So you don't have to worry about it.
Can we get a new book?
Second semester, yes.
You get a new book second semester?
Yes.
That makes a lot of sense.
We have a second semester workbook that we'll get second semester.
Do we have to pay for it?
Yeah.
How much?
$200. I always have the workbook in my thing. If you ever want to print them off, you can always do that. But you have to go find it at school that you can click on it. All right, let's take a look at this homework. All right. So solving by substitution, that's what we have been doing. This is a newer concept. Sometimes it makes the mind hurt a little bit because it's different, right? Does everyone have a worksheet now? Or a note sheet? All right. So, and again, we say we're solving by substitution because graphing doesn't always give us a good representation of what the answer could be, especially if it's a fraction or a decimal answer, like the x comma y is a fraction or a decimal, or if our graph isn't large enough and they happen to intersect each other way off the graph. But I think today we're going to have a couple of different scenarios take place because we talked about this. 3 things can happen when we graph a line. They can cross each other, which gives us that one solution, which is x comma y. That's the solution to the problem. sometimes they can be parallel to each other. If they're parallel, they don't have an x comma y, okay? Which means there's not a solution. And sometimes it's the exact same line on top of the other line, which means we have infinite solutions. So we have to take a look at the events that might take place if we have parallel lines or the same exact line, because something different is going to happen with our equation. So let's move forward. All right, so solve the following. So if we take a look at problem number 1, I have y equals 2x plus 5. The second problem on number 1 is 2x minus 3y equals 5. So first item on the agenda, do we have a letter equal to something? Yes. The first equation, we know that y happens to be equal to 2x plus 5. Agreed? So what am I going to do with that 2x plus 5 in the second equation? Plug it in. It's going to go right in there, right? So 2x minus 3. I'll leave a space for a sec. What had been here?
Y.
A y. What's going to go there now? 2x plus 5. Okay? Seems like everything we've worked on, this might work out nice. So I get 2x. Distribute the negative 3. Negative 3 times 2x, negative 6x. Negative 3 times negative 5 is negative 15 equals 5. Okay? If I combine 2x and minus 6x, 2 minus 6 is? What's 2 minus 6x? Negative 4x, thank you. Okay? What's the next step?
Minus 15. Subtract 15.
Almost.
Add
Negative. Yeah, right? Add 15. Gets us 20, right? That works out nice. So negative 4x equals 20. Divide each side by negative 4, so I wind up with negative 5. Okay, so I get negative 5, comma, blank. That's an x and y value. Okay, what letter am I going to look for now? I have y. Does one of the equations say y equals?
Yes.
Yeah, so what am I going to, which equation am I going to use? The top or the bottom?
Top.
Top. If I use the bottom, I get the same answer, which is awesome. But I'm going to use the top equation. So I'm going to take negative 5 and plug it in right here. So I get y equals 2 times negative 5 minus 5. Y equals negative 10 minus 5. Negative 10 minus 5. Something costs $10, something costs $5. How much do you owe?
Negative 15.
Negative 15. Good. So the solution to this problem is negative 5, negative 15. That seems similar to what we've been working on. But hey, let me ask you all this. Most of the grids I give you are from negative 10 to positive 10 in both the x and the y direction. What do you see with this solution? Huh? Yeah. So if you had graphed this on the graphs we give you that go from negative 10 to positive 10 in both the x and y direction, what happens with our crisscross of our graphs? Yeah, it's off the graph, right? So this gives us a pretty clear look when graphing might not work for us, okay? Okay, does everyone feel good with that first problem worked out? Okay, again, that's the same we've been working on, but this one really did identify, saying, hey, negative 5, negative 15, negative 5, negative 15, that's way down here. It's off of our graph where they cross. Okay? Problem number 2, I have y equals 4x minus 1, 8x minus 2y equals 2. Are one of them already presenting x equals or y equals?
Y.
Y equals, which equation, top or bottom?
Top.
Top. So I'm going to take that top equation, which is this, and I'm going to plug that in where? There you go. Good. It's going to go in parentheses. So I get negative 2, parentheses, equals 2. What had been here? What was here?
Y.
Y. What's going to go there?
4x minus 1.
4x minus 1. All right. What am I going to distribute over? Careful, careful, careful.
Negative 2.
Negative 2. Good. Here. 8x minus 8x plus negative 2 times 1. Negative 1?
Yeah, but it's
Ne-
negative.
2 negatives, so it's positive, and then 2 times 1 is?
1. Wait,
2.
2 times 1 is 2.
Yeah, there you go. Does anyone see something that's going to take place here?
X is going to cancel.
Yeah. The x's canceled each other out. So I wind up with 2 equals 2. that true? Is 2 equal to 2?
Yeah.
Yeah, I can't argue with that. But my x's are gone. So let's think for a minute. These lines aren't crossing each other. Not at one point. They're the exact same line. They lie on top of each other. How many solutions do I have in that situation? Infinite. So this is the exact same line, just presented at one is in standard form, one is in slope-intercept form. So this is the same linear equation. These would be the same line, so you have infinite solutions. And the reason you know it's infinite solution is your x's or your y's, whatever, one of the letters falls out completely. It's gone. It cancels out. So when it cancels out, it either is going to create a true or it's going to create a false. What do you think a false situation is? What kind of straight lines would those be? Yeah. Well, it could be this and this. Could be this. Could be this. They're parallel lines. So if this kind of scenario takes place and this becomes like a weird thing, like 7 equals 3 or something, that means they are parallel lines and they don't cross. And if they don't cross, how many solutions do we have? We don't have any. No solutions. So this one's infinite because the x's fell out. It created a true statement. All right. Next problem. Do you agree that we know this?
Yeah.
What am I going to do with that? Plug it in right here, correct? So I get 3 plus 3x plus 12. What had been here on the second equation? Y. What's going to go there?
Negative x plus 8.
Negative x plus 8. And then distribute over here, so I get negative 3x plus 24 plus 3x plus 12. Negative 3x and 3x. What happens here and here?
B equal 12?
What happens to the negative 3x and 3x?
They cancel each other out.
Oh, is it equals 12? Did I goof up? Oh, shoot, that should be an equal sign right here, right? In here? So I wind up with 24 is equal to 12. Do we change atmospheres or something? Is that something that should happen? Is that nonsense? I don't know. Is 24 equal to 12? That doesn't happen. So these would have been parallel lines. This is no solution. These lines would have been parallel to each other. Okay? Problem number 4. I'm going to modify this top equation to give me this. X equals 10 minus 2y. What did I do to that top equation? I just manipulated it to allow us x equals something. So now I know x equals something. I'm going to take this. Here, bless you. What am I going to do with that? Plug it in right here, right? All right, so I have 2 parentheses minus 3y equals 13. This had been an x. Yes, sir.
Why did you do that?
Why did I modify that?
No, instead of you putting in 2 or how you put in the parentheses after all you put it right before the 2.
Why did I put it in parentheses? Because that had been an x.
I'm saying right there instead of after the 3, the negative 3.
Oh, because I'm only plugging in for the x. The minus 3 comes along for the ride. Okay, and then for order of operations, that'll allow us to distribute just the 2 over that. So if I get that and that, I get 20 minus 4y minus 3y equals 13. Like terms, oh, sweet, nothing fell out. So what does that mean? What am I going to do here? Subtract 20? If I subtract 13 minus 20 is negative 7, I believe. So what's my y value? So we have a solution here, yes? Y equals, plug it in here, 10 minus 2 times 1. 2 times 1 is 2. 10 minus 2, 8 comma 1. This is a real solution. Those lines crossed each other. Sweet. All right, so this is what my plan is. I would like for you to get page 144 and 145. I want that done. for tomorrow. Okay? And I would like you to try on page 146, just 1 through 6. Okay? That'll be for tomorrow. Gotcha? Guys, girls, have a great day. Take care of one another. My newer students, come on up. I want to show you something real quick.